So my name is AISYAH AZIZ, and today I'm going to be presenting my individual video presentation on the topic non-destructive testing. So in this topic, I will explain to you guys about 4 methods of NDT. That is, the first one is dye penetrant testing, magnetic particle testing, radiographic testing, ultrasonic testing, and last but not least is the list of reference. So the flow of presentation is very simple. First, I will give you guys the definition, and then working principle, and then working procedure, advantage and the disadvantages, example of application, and last but not least we have the list of reference. So the first one is dye penetrant and magnetic particle testing. So in this one, DPT or dye penetrant and magnetic particle testing is a widely used method to locate surface breaking defects in all non-porous materials. It can also be used in non-ferrous materials and also ferrous materials. So the principle of DPT is carried out by applying red dye penetrant. So we apply that to actually visualize the defect so we can actually see it. And DPI is based upon capillary action where low surface tension fluid penetrates into clean and dry surface, breaking any discontinuities. So the working procedure for this is we have inspection steps. This is very crucial. So first we have the pre-cleaning. So the test surface is to be cleaned, absolutely cleaned from any dirt, paint or oil or grease, so it needs to be free from any kind of contamination. So second step is application of penetrant. So this step, the penetrant is then applied to the surface of the item that is being tested. So we give it a dwell time. The dwell time usually takes from 5 to 30 minutes where the penetrant will soak into, and the dwell time will mainly depend on the penetrant being used. So step number 3, we have excess penetrant removal. So this is also very important. So the excess penetrant is removed by penetrant removal such as water washable or lane-free cloth. So if we don't remove it, it will affect the result of the test. So number 4 is application of developer. So after excess penetrant has been removed, a white developer is applied to the sample. So several developer types are available such as aqueous wet developer, dry powder, water suspendable, and water soluble. So the choice of developer is actually up to the penetrant compatibility and also inspection conditions. Alright, so moving on to step number 5. It is inspection. So the inspector will use visible light with adequate intensity to actually see the dye penetrant. So inspection of the test surface should take 10 to 30 minutes. So it's very quick. So it depends on the product kind. And number 6, last but not least, we have the post-cleaning where we will clean the test surface and then record any defects, and especially if post-inspection coating processes are scheduled. Alright, so the advantage of this test is that the test is low cost, and then using this test we can actually use it to large areas and large volume of parts, and then it is simple to use, we get rapid results, and it is sensitive. But the disadvantages are it can only apply to surface defect only, little indication of death, surface preparation is very critical, and only surface breaking defects can be detected, and last but not least, chemical handling and proper disposal is very crucial. So here is an example of application in ship repair. So in figure 6, we can evaluate indications in the spin hole plug well. Most of the dark red indications are rejectable defects. So this is how we apply this test in ship repairing. So the next one is MPI or magnetic particle inspection. So magnetic particle inspection is also non-destructive test, and it is for detecting surface and slightly subsurface discontinuities. So MPT is carried out by magnetizing the sample. We spread a fluid of magnetic particle or ion particle, and then any discontinuity or defects will show up. So the working procedure for MPI, a ferromagnetic test specimen is magnetized with a strong magnetic field, and that magnetic field is created by magnet or special equipment. So if the specimen has discontinuity, it will show up because it will interrupt the magnetic field flow through the specimen, and a leakage field will occur. So we use a dye pigment to the test specimen. These particles are attracted to leakage fields and will cluster to form an indication directly over discontinuity. So this indication can be visually detected under proper lighting conditions, so we can actually see them. So the next one is advantages and disadvantages. So The advantage of this test, it can detect subsurface defect, it is simple to use, it gives us rapid result, little surface preparation, considered low cost, and then very portable inspection method. And the disadvantages, magnetic particle inspection will only work with ferromagnetic materials. It will not work with other materials. So number 2 is it needs exceedingly large currents, and then care is necessary. So care is necessary because we want to avoid local heating and burning. So next one is application. We use it in aircraft structures, structural steel works, shipbuilding, pressure vessels, boilers, penstocks, and etc. So we actually use it in ship repair and also shipbuilding. So the next one is ultrasound testing. So in ultrasound testing, it is a method of characterizing the thickness or internal structure of a test piece. So usually it is beyond the limit of human hearing. We use 500 kilohertz to 20 megahertz. So the high frequency sound waves are very directional. So when they travel through a medium like piece of steel or plastic, they will encounter boundary with another medium like air, and at which point they will reflect back to their sources. By analyzing these reflections, it is possible to see whether or not we have any defects, any air, or we can also measure the thickness of the object. So we use the high frequency, like I said before, 2 to 5 megahertz. So the next one is the working principle of ultrasonic testing. So ultrasonic waves are introduced into a material and it travels in a straight line, and it also has a constant speed until they encounter a surface. So at this surface, it will reflect back. So the amount of reflected or transmitted energy can be detected and provides information about the size of the reflector. So the reflector can be anything. So it can be a plain surface, it can be defects, it can be air, anything. So we can actually measure that. So the advantage is it requires, if we want to measure the thickness, it only requires one-sided. There are no potential health hazards like associated with ultrasonic testing, unlike radiography, and the results is very reliable and repeatable. So the disadvantages is, of course, we need a trained operator, which is hard to find, and then second one, ultrasonic thickness gauge are much more expensive, and then the applications require a wide range of thickness measurement or measurement of acoustically diverse materials may require multiple setups. So the application is applicable to almost all metals and non-metals capable of detecting surface and internal discontinuities. So it is very suitable to be used in ship repair and shipbuilding. So the last one, we have radiography testing. So radiography testing is also NDT method of inspecting hidden flaws, and we use electromagnetic radiation such as X-ray or gamma ray to penetrate through these materials. So it will detect any defects. So the working procedure is basically the principle of radiation that is absorbed and scattered as it passes through the object, and if there is any defects or variation in thickness, it will show on a film, and then flaws will show up as usually a dark area or dark spotches. So advantage of this method, it can inspect assembled components, and then we don't need a grand surface preparation, and then it will detect both surface and subsurface defects, provides a permanent record, and then verify internal flaws on complex structures, and then isolate and inspect internal components. The disadvantage is the cost. It is relatively high, and then the inspection takes a long time because it is so slow, and the most important one is that radiation is very harmful to human, so we need to be prepared by wearing protective measures. So here is the applications of radiographic testing. We use it in aerospace, military, offshore industries, marine industries, power gen, petrochem, waste management, automotive, manufacturing, and also transport industry. So it is a widely used method, but it is also very hazardous and very dangerous to humans' health. So adequate preparation is very absolutely necessary. So here is my list of reference. As you can see, I use many websites to help me understand more about the chapter and the topic that we are discussing today, and mainly I use my a lecture note from Ship Repair and Maintenance System, Chapter 6, that is Supervision, to help me furthermore understand. And yes, I think that concludes my presentation for today. Thank you for listening.